Let's take a closer look at the use cases that EESSI actually enables, because it goes, or we think it can go beyond, or way beyond, just giving people the same software stack everywhere. It actually opens up a couple of doors that are interesting, that we think are not really possible or feasible with the way things currently are done. So this is the bullet list of the use cases we think EESSI enables. I'll go through them one by one. Now, we also discussed these at more length in our EESSI paper, so the open access paper, so you should definitely take some time to read that. It's not a short paper, it's about 30 pages, but it explains everything from essentially zero, the motivation, why we're doing EESSI build, all of that, how it's designed, what it enables, and how we see it going forward. So first of all, a uniform software stack, the same software everywhere, regardless of whether you're using your own laptop or server or workstation, whether you're running on the cluster, running in the cloud, it doesn't really matter. As long as CVMFS is installed there and the EESSI configuration, and that should be hopefully easy enough to do, you can get the same software environment everywhere. The long-term goal is to, well, it's actually already a goal, to support a wide variety of systems. Intel and AMD, of course, because that's still everywhere. ARM is becoming very, very relevant, and we cannot ignore anymore today. In the current version, we also support Power. We're considering not spending much of our time on there anymore because we haven't heard anyone up until now who's still interested in that. There's Power systems left and right, but they're really exceptions, and we definitely shouldn't spend our time on that. And what we do definitely want to spend our time on is RISC-V, so 64-bit RISC-V. So that's something we're starting to prepare for. In terms of operating system, any Linux distribution will do, as long as you can install CVMFS on there. There's pre-built packages for RPM, Debian, the standard stuff. You can build CVMFS from a source as well. It's not that difficult. You only need the client side of it. Since you're not going to run your own CVMFS server, you're going to talk to ours. So it's pretty lightweight even to build it from source if you have to. On Windows, we're mostly looking at WSL, so Windows Subsystem for Linux. Jaco has played with it there before. You can start graphical applications that come from EESSI, or the software comes from EESSI under WSL. It works fine. So that's already very good. macOS we also see as a longer-term goal. Right now, we're not focusing our efforts on it because getting CVMFS working there is already not trivial. There are some recent developments there that should make it a lot easier. So Fuse implementations for macOS. If we want to support macOS properly, we'll need a separate compatibility layer there because it's different enough from Linux that we cannot use the compatibility layer that was built for Linux on macOS. That just doesn't work. So it's like a fork in the tree, and we need to rebuild everything again for Mac. It's all automated, so that's not very worrying. And I think once we get the compat layer working, we're basically in Linux land again, and it should be okay. We think. We haven't tried it, but that's definitely future work. High-speed interconnect or Ethernet and different versions of that is definitely what we want to support. OmniPad, the, let's say, less common fast interconnects as well. All kinds of different GPUs that we see coming up. So all of that we want to definitely support. And we want to do that without compromising on software performance. You're still getting optimized builds. Still getting builds that are optimized for your particular type of CPU. If we don't have knowledge of your CPU, EESSI will fall back automatically to something that's compatible. So that's something that hasn't really been mentioned yet, but let's say there's the next version of AMD CPU, Zen 4 is there, and you get very early access to a Zen 4, you can still use EESSI, it's just going to fall back to Zen 3. It's going to work, you're going to get optimized binaries, so not something that's totally generic, but it won't get the absolute maximum out of the CPUs yet, since it may not be using some instructions that are very helpful on Zen 4. AVX 512 is coming up there, I think. Yeah.
Is it optimization per CPU or per, let's say, instruction set?
It's instruction set based.
Because Milan, I think, is going to do AVX 512.
Yeah, well, no, Milan not, the next one, whatever it's called. Genoa, yeah. So there's different things there. If you just purely look at instruction set, you can run a Skylake binary on an AMD Genoa, or you will be able to. That should work. It depends on whether they support all the instructions, right? But we also know that compilers make decisions when compiling binaries, not only based on instruction set, but also based on processor features, like how big is your cache? And we had the discussion on this earlier, Milan and Milan X. So Milan X has way bigger caches, for example. You can run the exact same binaries on there, but there may still be a benefit of recompiling specifically for Milan X. And that's something we haven't done yet. So right now we have one Zen 3 branch. Maybe we need to add a Zen 3X and then enhance the detection a bit so it knows it's on a Milan X rather than a Milan. And maybe there's an added couple of percentages or maybe bigger, we don't really know.
No, let's first verify the impact.
Yeah, of course. So we have to check whether it's worth doing that, whether there's an actual impact. But for some things that are very cache sensitive, OpenFOAM comes to mind, there may be an extra couple of percentages, 10% maybe. Is that enough to have a separate stack? If everything is automated, why not? So if it's very easy to just support a fork in the road there, we'll probably just do it. And the same applies to Skylake and AMD Genoa. The same applies to Graviton 2, Graviton 3. So the reason that currently our detection is recognizing or detecting an Ampere Ultra in Azure as a Graviton 2 is it because it's basically the same instruction set. So the binaries will run, but maybe we still need a separate software stack for Ultra for different reasons. And that's something we haven't really tried yet. Also because the detection mechanism needs a bit of work. Yeah, but it's a very good question. So grab a sticker. Finally, yes. And yeah, of course, this whole story, it facilitates if you want to jump from your laptop to the HPC, if you want to do cloud bursting, becomes a lot easier if you have the same software stack everywhere. Now that's, let's say, the core goal of EESSI, but there's stuff that suddenly become worth thinking about thanks to this. Now one maybe obvious one is that you can also use EESSI in CI environments, in GitHub Actions and Jenkins. You mount the software stack, you have all your dependencies, you have all different versions of GCC that you can test your software with, and all you need to install is CVMFS. You don't need to install 100,000 packages with different libraries that you need. No, if everything is included in EESSI, you can just use it from there. And even additional tools like Reframe, for example, we can provide in the compatibility layer. Even that you don't have to install, you can just use it straight from EESSI. Especially in CI environments like GitHub Actions, everything is downloaded on the fly anyway. Usually you specify it yourself with yum install and God knows what. CVMFS takes care of that for you, so your workflow file even shrinks quite a bit as well. Yeah, so you get CVMFS in there, it works. We have examples of this, I think, on the next slide. Yeah, so we played with this a bit, it was pretty easy. This is a standard GitHub Actions workflow, it looks pretty obvious. We're using a GitHub Actions action, I think it's called in here, that knows about CVMFS. So you can just tell it, I want to mount this repository, and I also want to install this configuration package because I know that's needed for this one. And in terms of proxy, yeah, screw it, I'm just going to talk directly to Stratum 1. Yeah, and so you give it all the necessary information. The action makes sure that CVMFS repository is mounted, and then you can straight ahead go and source the init script and run some tests, whatever you're doing. So that's pretty cool. Looks like this, right? So if you click the link here in the slides, you can see it in action, what happened there. This is our EESSI demo repository where the scripts that we're providing for Bioconductor, GROMACS, OpenFOAM, TensorFlow, we actually run these in CI to make sure the scripts work. And that's very easy thanks to EESSI because we don't need to install all that software, it's just coming straight from there. With a bit more effort, we can have something custom for EESSI, so a custom GitHub action for EESSI, and then you don't need to tell it about all these details, it knows, and it just does the same thing way more lightweight. So with a single line, you're basically getting a very rich software stack, and you're running stuff that's optimized for the runner where your CI tests are being run. So it detects if it's on a Haswell or on a Skylake, it's going to use different binaries, and it's going to speed up your CI run as well. Yeah, so we think that's a very useful thing, and that maybe software developers should be relying on as well for their CI stuff. Same screenshot, but then with the custom runner, the custom action for EESSI. Another thing this can facilitate, and Alan already briefly mentioned that, is HPC training. So if you want to teach researchers how to use a Slurm cluster, maybe you don't want to do it on your production cluster if they by accident submit 100,000 jobs, which is very easy. Maybe you want something throwaway where they can play around, and if they mess something up, it's fine. We just throw away the cluster, we start over again. Cluster in the cloud, which we use to give you the account for the hands-on, is one way of doing that. Magic Castle is another. There's custom solutions like AZ Hub for Azure, or AWS has their parallel cluster, I think. It's all really the same thing. It gives you a Slurm cluster in the cloud that you can burn down whenever you don't need it anymore. It gives you a Slurm cluster, it gives you worker nodes and all that, but there's no software. I mean, in terms of scientific software. So EESSI can fill that gap. So it becomes very easy to set up a throwaway cluster in the cloud, even for software-specific trainings. LAMPS, GROMACS, if it's included in EESSI, it's just there. People can start using it and don't have to worry or fiddle or lose time with getting it installed. And as an added bonus, after the training, people can get the same software environment very easily. So if they don't have access to the cluster anymore, or they want to use what they learned at home or on their own HPC cluster, if EESSI is available there, the jump is a lot smaller than setting everything up again. Another use case or possibility that EESSI enables, and I think this is a very interesting one, is it enables or allows to collaborate with the developers of the scientific software themselves way more closely. So if we have a central software stack that's used by a lot of people, hopefully in the future, researchers, HPC centers, clouds, you can get it everywhere. It becomes a very interesting target to step to the developers of, say, GROMACS and say, we provide this in our software stack, lots of people are using it. Can you please help us make sure that it's properly installed? It has all the bells and whistles. It's properly performing as you would expect it to as a software developer. Testing it, is everything working as it should, and so on. So the plot that Caspar showed with the 1 nanosecond per day of simulation versus 1.6 nanoseconds per day if you use the proper binary, is that good? Could we go to 10 nanoseconds a day if we're enabling some feature of GROMACS we don't know about? Who knows, right? And we have 1,000 software packages, so it's impossible to figure that out by ourselves. But if we step to the software developer and say, let's spend an hour with us and see how we configure GROMACS, and you do your tests that you usually do when you do development. How does it work? Are you happy with it, or should we change something? And if they're happy with it, we can put in our documentation approved by developers, and it gives people a bit more confidence that it's properly done and they can rely on it working as it should be. There's a win-win there as well. The software developers themselves will hopefully get less questions about installing their software. If it's available in EESSI, they could just say, if you don't know what you're doing, go to EESSI and you'll be happy, right? So there could be a win-win there as well. And they probably, or maybe don't even need to spend time on building binary packages anymore because their users asked for something. OpenFOAM is an example of that, and I've talked to the OpenFOAM developers. They spend a lot of time in building binary packages and checking them, making sure everything is okay for Ubuntu. If you're using some other OS, good luck, we don't give you anything. And from their side, it makes sense because the effort explodes. Again, ARM and all these things, all these targets, it becomes impossible. We can probably relieve them from that burden. And of course, they can use EESSI themselves in CI for their dependencies to test the different compilers and so on. So I think this is a very interesting story. And this only becomes possible because you have a central software stack. If we, as UGent, go to the OpenFOAM developers and say, hey, we'll give you an account on our cluster if you check our software, they're probably never going to reply to that email, right? But if you say, we have a central software stack that's used by hundreds of HPC sites and thousands of scientists around the world, maybe they pay attention. And yeah, we plan to step to some of the bigger packages there and see if that's possible, what kind of questions we have to ask them, how much time does it take to help them validate the installations we provide, does that actually work? So that's something we'll explore as soon as we're ready to do that. Portable workflows is another And especially in bioinformatics, people are using SnakeMake and these workflow tools that talk to 100,000 different tools. Of course, you need to have all of these things installed. Very often they're using containers for that. So again, suboptimal binaries and all this. We see a role for easy there as well. If people say, use this workflow and you have easy mounted and everything works nicely and is fast and has very little effort. So that's also something that becomes more possible or very attractive. Another thing we can do that's more a bit community specific is we can provide a custom module tree for some community. So for the bioinformatics community, you could see we can tell them if you use this part or this option when initializing easy, you will only see bioinformatics software because you probably don't care about OpenFOAM or anything else. So that you get like a zoomed in view of what we provide. Yeah.
I don't want to push the discussion too deep right now. So break it off if you want to. Have you thought about actually adding scheduling software, especially Slurm clients, to the stack? Because a lot of the MPI stuff and so is having
integrating with Slurm.
Integration with Slurm and maybe some of the other scheduler clients as well.
It's worth looking into. I'm not sure if that would work well, but we can definitely try it. And that would be something for the compatibility layer because you only need one Slurm, regardless of whether you're a Haswell or an AMD ROM, or you probably don't care.
True, but the versioning may be a little bit tricky there.
Well, we have versions of the compatibility layer as well, so we have like generations of that. Yeah. So Slurm could evolve along with that. Maybe, I don't know.
Yeah, cool.
I don't see our sysadmins going, oh, Slurm isn't easy, so we'll just use that, and we don't have to manage Slurm anymore. I don't know. In the cloud, it's maybe a different story.
Make some of the migrations easier because doing system-wide Slurm upgrades on computers on big machines is not trivial.
Yeah, maybe someone can play with that and see. Yeah, that's what I had for this this slide deck. So we're breaking up the introduction to easy into smaller parts to make it a bit easier to digest, but that's what we have. Yeah, time-wise, we're now exactly on time, I think, in terms of target. The next one. Sure, yeah. Oh, I don't know. We can take questions.
If you're on Zoom, you can just unmute yourself.
Have another drink and then start again. So I'll take 2 or 3 minutes before we.
Actually, there was a couple of questions in the in Slack or comments questions.
Yeah.
There was some things about supporting different shells. Maybe that's for the previous talk. In this one, there was a little bit of discussion about the Mac layer, like how far we got in the past. So I think to what Terry was saying is that basically we got it to work.
At some point, yes, but it was very fiddly and
it only worked with a certain version of Mac and
that was around the time when they started switching from Intel CPUs to ARM CPUs. So that was a painful thing to redo again, and we weren't happy with it certainly. I think there's something mentioned at the CVMFS workshop last week as well. There's a new Fuse plugin or something like this that doesn't require root anymore, I think. Where there was Mac Fuse, which you needed to get CVMFS working on Mac, but Mac Fuse required root permissions to install and was very difficult to keep maintaining because Apple keeps tying things down, and not even if you're root, you don't have full access to your own machine. With the new Fuse library, that's solved because you don't need to fiddle with system stuff anymore. It's all user land essentially. So that should make it a lot easier to get CVMFS working, which was the main pain point. I'm not sure. I think Terrier was playing with building Gen 2 prefix on the Mac, but outside of CVMFS, and got that to work at some point. But I'm not sure we really looked into the CVMFS part of it. So you need both essentially to actually get started.
The other question was about CI. So if you're doing CI, are you like, do we have squid processes in front of that, right? So are we just continuously hammering our own servers, right, by downloading
As
and
it is
downloading
in the
again?
slides, we're hammering our own servers.
So I mean, there is probably a comment to make about that, that we can make the CVMS configuration a bit smart, so that we hammer the server that's inside the Azure network. So we do have stuff that's inside the Azure network.
CVMFS should do it by itself.
Well, it does geolocation, right? So not necessarily. So it uses geo servers, right? So it's not necessarily.
Yeah, I'm not sure.
It might not be aware that I should only be using.
It's in the same.
That should be easy.
I think it's something we should think about anyway, but also in general, in terms of our caching, I don't know if there's much we can do there apart from figure that. At least I can't think of it.
Yeah, okay, but it doesn't refresh. So I'll have to grab it again and.
And with that,
So
we had a
just
couple of
snapshot and
discussions
create the
regarding
account, and
squids
that's it. It doesn't look at it again.
yesterday and the day before.
Okay, so.
Some
No,
of
that's
the
fine.
tricky things with the HPC usage of CVMFS is that basically the amount of times you're actually going to pick up the software is way less than some of these high throughput folks are doing. I mean, we're talking about a dozen nodes that are picking up a couple of binaries instead of 100,000 of those repeating cycles. So.
Any other questions? If not, I'll stop the stream.
I mean, so you have a repo that provides the CVMFS configuration, but you don't actually have to rely on that. You could modify that to change to only a certain subset of the hosts if you wanted to do, like, if only my nodes talk to my server. So you could remove some of the other hops along the way, couldn't you? Or am I misunderstanding how you can reconfigure certain BMFS? I'm just trying to help solve the how can I make this so that it's not hammering our own service problem. The answer is yeah, that would work.
Yeah.
Modify the hosts that are defined in the easy config.
Yeah, that's what I was suggesting as well.
We could have a custom easy configuration file for GitHub Actions, and you can probably detect in which zone you're being run. Or
Probably. But I mean, then you're looking at stuff globally, whereas your site-specific stuff is like, well, we might as well just run over a tier 1 or a tier 2 and then just go, we'll just hammer ours because it's literally there on the other side of the data center, rather than just having stuff constantly bugging you guys. That might be.
I mean, at some point we'll know as well. If we see Stratum 1 being hammered and it's consuming lots of bandwidth, yeah, then the trick is going to be where's it coming from, because that's what CVMFS admins and maybe people who are familiar with CVMFS can contest to that. But that's something we see coming up in discussions in the monthly meetings as often as well. Like, okay, this Stratum 1 is being hit. Like, is it you? Are you actually using a proxy yourself? And often they're quite good at like, based on IP addresses and just traffic coming in, they can zoom in, and it's probably these guys not doing the job that they should be doing. So not using a proxy or things like this. Yeah.
Or scanning the entire file system.
Yeah. So if we get popular, we may have to start paying attention to that to make sure the network remains performant. We'll see.
Kenneth, can you hear me?
Yes.
Oh, God, yeah, terrifying. It's also worth noting that when we get monitoring up and working at scale, we will be able to track outgoing bandwidth pretty steadily from Stratum 1 if they use the monitoring package we are going to be shipping.
Yeah.
So that should be very possible to just monitor, track, and actually see how load distributes across both our network and out to other like third-party users.
Yeah, and I think it's relatively easy to see it's consuming lots of bandwidth, but zoning in on where that's coming from or who is causing it is difficult, I think.
So it shouldn't be that bad, but yeah.
If it becomes really popular in CI, we will know quite soon, I think.
Yeah.
Either someone will
thing-
send us a bill, or everything is going to become unresponsive.
One thing that is interesting, though, is if we have a lot of people using GitHub Actions, they're probably going to hit the same Stratum 1 due to geolocation.
Yeah. Yeah, and that's something I discussed with Hugo as well. We could make sure there's a Stratum 1 per Azure region, and maybe that's enough in practice. I mean, since that's essentially internal traffic, right? Doesn't go outside of the, of the zone.
Should be.
Yeah, then it may be good enough. Maybe then we don't care that it's being hammered. Yeah. Yeah, and those Stratum 1s don't have to be part of the public network as well. So there's a difference between what I call a public Stratum 1, which is included in our EESSI configuration and where everyone who connects to EESSI can connect to, and private ones that only you know about. So you can set up your own private Stratum 1 on an HPC side and not tell other people about it. And you just have your clients connect to that rather than to the wide network of Stratum 1. So there's a middle ground as well. Yeah. No, maybe to close that down, keeping CVMFS running at scale in production is definitely something we don't know about yet. So the repository has been there for a long time, but not many people are using it. I don't think we've had any big issues. We had a Stratum 1 once, which was behind a bit, so was serving an old revision. So one of the Stratum 1s in our network was serving an old revision. That was interesting to first of all realize that was the problem that was going on. And yeah, things like this we'll have to learn how to deal with, I guess. We'll see how that goes. There's, yeah.
Quite close contact with a group who is very well aware of running this at scale.
Mm-hmm. And also we have good contacts with the CVMFS developers themselves as well. Bob and I have been, I should say, trying hard to join the monthly meetings, mostly to listen in. It doesn't always work out, but yeah, we're also trying to make sure we are in close touch with them. So if we need to talk to them or need to help them to figure something out with us, we can. And it seems they are actually quite happy with EESSI in the sense that they see EESSI combined with the Alliance, right, Compute Canada, as a way of breaking into HPC, because they've been having trouble getting into that space because it seems like lots of HPC sysadmins are reluctant to install CVMFS on their cluster. Jitter, and I see Caspar nodding, so there's reasons. So for them, they've been, well, not really actively pushing, but they're a bit disappointed that it's not getting into that space. And with EESSI, they see that changing. So there's actually a bit of interest there as well, which may help us if we need some help or things like this. Okay.